Okay, we will go through some important points in the class 12 max chapter 6 application of derivatives. So before reading this chapter you should know how to find the derivative. Okay, that is how to differentiate a function. Then we will see the definitions in this chapter. You should know these sine and cosine waveforms, how it looks, how to factorize polynomials. Then you should try to do a few examples on each topic in this chapter. So what is composite function? One function inside the another. Okay. ds by dt means what? How do you read it? We mean rate of change of distance. Here they are taking a distance with respect to time t. Okay, t is for time, s is the distance, is a rate of change of distance with respect to time. This is why ds by dt. See, at this particular instant you write this, okay, at x equal to x0. Now what happens if two variables are changing with respect to one variable, say time, x and y are varying with respect to time, then dy by dt divided by dx by dt at ds by dt, because this is a denominator, they are not equal to 0, then it become infinite. Okay, this is called a chain rule. So here find the rate of change area of the circle. So here you should know what is the area of the circle formula, pi r square. So they are asking how area is changing with respect to r. So with respect to r, that is the denominator dr, and the top is dA, rate of change of area dA by dr. Okay, so dA by dr, you have to differentiate this area, then you substitute at 5 centimeter, where r equal to 5 centimeter. Look at this unit here, 10 per centimeter square per second. Okay, because they are asking area, rate of change area per second. Area means cm square. Here it is given cm, it is given meter, means meter square. So here the volume of the cube is increasing at the rate of, okay, dy by dt, dv, volume means v, dv by dt is given. They are asking how the area is changing. Okay, when the length is, area is changing with respect to its side. Okay, given one information, they are asking on the surface area of the cube with respect to the side. Okay, now dv by dt equal to this much, 9 centimeter square. So this is the volume of the cube. Volume means x cube. Okay, volume means x cube. Then you differentiate. So look at here, dx by dt. Okay, this is side, because it is given x, so we are differentiating with respect to x, volume with respect to x, but they are asking, they are given volume with respect to the time they are given. Okay, dv by dt, by chain rule we are using gx here. 9 equal to 3x square. So 9 by 3x square is 3 by x square. Then after substituting in terms of length, you will get this. For each question here, you should think what is given and what they are asking, what is changing and what they are asking. Based on that, you should try. A stone is dropped on the clay waves at a speed. Okay, this is given. Okay, this is the radius, nothing but the radius. At that instant, the radius of the circuit 10 centimeter, how area, enclosed area is increasing. Here also area of the circle. Okay, this is 2 pi r into dr by dt. Okay, again based on the formula, you see why they are putting dr by dt here. Okay, this is r. With respect to r, we are differentiating. Okay, but we are asking with respect to time. Okay, how fast encoded area is increasing. Dy by dx is positive if y increases x, y increases as x increases, and a negative if y decreases as s increases. Length x of the rectangle is decreasing. Okay, so and you say decreasing, we are using the negative sign, increasing positive sign. Perimeter of the rectangle, two sides are equal in rectangle, so 2 into x plus y. Rate of change of perimeter, okay, dp by dt. Okay, after substituting this value dx by dt, okay, dy by dt, you will get this. Then area of the rectangle, here we are going to use the product rule from our chapter 5, uv rule, that is u dash v u v dash. The total cost of rupees the production. Okay, here how they are using the derivative, rate of change of the total cost, rate of change of the total cost with respect to the output x is the number of unit. Okay, here rupees associated with the production of the number of x units. Okay, x is units, dc by dx. Okay, so here you are directly differentiating with respect to x, so no need to add some dx by dt at the end. Here we are differentiating cost with respect to unit here directly. This is the marginal cost, this is marginal revenue. Similar thing with after integration you substitute. Here you at least try these problems, try to do most of the thing, at least try this. Increasing decreasing function. Okay, here whatever domain they are mentioning, you should know what is this. Here R, this is domain of real numbers. So what are real numbers, what are the numbers included in the real number domain, you should read. Okay, this is x is the member of the real numbers, real number domain. So now for this function, if you take x negative value, then this is the f of x. For this x, this is f of x, that is square of minus 2, x square. Okay, minus 2 is 4. Similarly for positive side, this is coming, then using these two values you plot this curve. Now function is said to be increasing for x is greater than 0, decreasing x is less than 0. Now for the definition 1, let I be the interval associated with the domain of the real function. Okay, is increasing means what is the definition? x1 is less than x2, that is x2 is greater than x1 on that domain. Okay, similarly decreasing constant. See here the decreasing and strictly decreasing, look at the difference here. F of x1 is greater than or equal to f of x2 here, but here f of x1 is greater than f of x2, so greater than equal to greater than, this is strictly decreasing, should be greater than equal to decreasing. These are the graphical representation, strictly increasing, strictly decreasing, neither increasing nor decreasing. So now we will see whether a function, increasing or decreasing at a point, okay, at a point here, this is at x0, let we are assuming. Okay, again you should understand this definition here. So now this example based on this definition is increasing in the domain R. Okay, show this is the proof. First derivative means after one time differentiating only once. Okay, so now for this theorem, this is a definition. F be continuous on, this is the closed interval. Okay, this bracket, that means it includes a and b. Okay, between a and b, including a and b, differentiable on the open interval. Okay, this is closed interval, this is open interval, that is without including a and b. Between a and b without including, this is a and b with including a and b. Okay, f dash of x is the derivative of the function f of x. F dash of is greater than 0 for this. This is increasing, decreasing, this is the definition. Constant function, this is the definition. Okay, this is the open interval and this is the closed interval. So this proof we can go through it using mean value theorem. See here, here including C means this is continuous. And f is continuous in the f is increasing, similarly less than 0 interval. Okay, it's continuous symbol added here. Show that the function f is given by is increasing in R in this domain, real value, real numbers domain is increasing. So f dash of x, this is the after one time differentiation. They are rewriting this in this form so that we can define this is greater than 0 for every interval of R, that is the in this domain, real number domain. Okay, so when this is plus 1, so therefore the function f is increasing in the R. So here f of x is cos x, so that is why I said first you should know how to differentiate functions. So cos x, after differentiation what will come? Minus sin x. Okay, in this interval. Okay, decreasing, increasing. So f dash of x is minus sin x. Derivative of cos x is minus sin x. That is why you should know the differentiation. Since for each x will 0 to pi in this interval, okay, sin x is greater than 0. From 0 to pi, if you take that sine wave, 0 to 180 degree, it will be in the positive value. Okay, positive value from 0 to 180 degree. This is the open interval without including 0 and pi. Okay, so that is a positive value. That means f dash of x will be negative. Sin x is positive, f dash of x will be negative. So f dash of x is less than 0. Based on that definition, that is decreasing. Okay, in this interval. Similarly, in this pi to 2 pi, sine wave will be below x-axis, that is a negative value, that is without including g and pi. So when sin x is negative, then f dash of x will be positive. So that is increasing in this interval. But they are asking between this is increasing, is decreasing. From 0 to 2 pi, it is increasing as well as decreasing. So clearly a and b above, neither increasing nor decreasing. Okay, because both is happening here. In this 0 to 2 pi, both increasing and decreasing is happening. So neither increasing nor decreasing. So here you see f dash of x, which f dash of x will be 0 when x equal to 2. Okay, so in this open interval, okay, in the open interval, not including 2, that is the open interval, not open interval between minus infinity and 2. This is the less than 0. Here let us say 1. Okay, not including 2. If you put 1 here, 2 minus 4, that is a negative value, that is the less than 0. Okay. Okay, similarly, if you take greater than 2, that is 3. If you take 3 here, 6 minus 4, that is 2, that is a positive value. Okay, so between minus infinity to less than 0, that is a decreasing. In this interval, also in this interval, that is greater than 2, that is increasing. F is increasing in this interval. So here also f dash. So now you should know how to factorize this. See, at what values of x, this f dash of x is 0. So in the previous your classes you should know this factorization. Then accordingly you divide this interval, then find each interval excluding that endpoints, what is the value of the function. Okay, here. So f is increasing in this interval, so they are asking in this interval. However, f is neither increasing nor decreasing in the r. Okay, r mean it includes everything. So these are all separate intervals. F is increasing, decreasing, but r means it includes everything. So if you include everything, then it is neither increasing nor decreasing, because both are happening here, increasing, decreasing within that interval r. Includes r, both positive, negative numbers is including. Okay. See here, important thing here in this is f of x equal to sine 3x. Okay, but the interval is given for the x equal to 0 to pi by 2. When f dash of x is 3 sine x cos 3x, then 3x you differentiate 3. So that is why you should know the differentiation. Okay, derivative. Now they are given the interval for the x 0 to pi by 2. But here is given 3x. Okay, so when x is 0, that 3x also 0. X is 5 by 2, that is 90 degree. When it is 90 degree, so 3x will become 30 degree itself. Okay, interval 0 to 90 degree they are given. Okay, here 3x equal to 5 by 2. The sine function which gives 3x is 5 by 2, 3 pi by 2. At 90 degree to 70 degrees, then it will be 0. Okay, this will be the sine function. This cos function is 0. You know, cos function, cos 0 is 1, cos 90 is 0. So okay, the 3x is 0 at 90 degree and 3 by 2. Okay, you should know the cos function here. So when here when you will get, if you 90 degree means x equal to 30 to 30 degree. Okay, 5 by 6. At that x 5 by 6, you will get cos 90 0. So 3x equal to 5 by 2, then x equal to 5 by 6. This 3x is 5 by 2, x equal 5 by 6. Then for 3x equal to 3 by 2, x will be 5 by 2. Okay, here when you put 5 by 2, 3x equal to 5 by 2, then x will be 5 by 6. And you say 3x equal to 3 by 2, then x will be 3 by 6, then that is 5 by 2. Okay, this is how you convert this to this, that is important here. Okay, here 3x is there is given for the x, so we are converting here for the interval here, that is important in this. Then after that you can other things is similar to the previous problems. So here also after differentiation, so at 45 degree cos x equal to sin x. At cos 45 degree also same, sin 45 degree also is same. So okay, this exercise again you try some of the things. This portion is deleted, tangents and normal. This also deleted. for maxima minima, how to find the maxima minima using the derivative. Okay, you can go through this introduction. So now this definition is important. Okay, these definitions you should remember. F is said to have a maximum value in the interval. In this interval I, if there exists a point C, so this condition, okay, f of c is greater than f of x for all values of, that is the maximum value, and this is the minimum value. Sorry, this is the minimum value definition, this is maximum value definition. Is either maximum or minimum. This is called the extreme value. Okay, so these definitions you should understand before going to the problems. Okay. So here this is the maximum value, this is the minimum value. Here no maximum minimum. Find the maximum minimum value of this in this domain, x in this domain. So that means in this domain means there are more numbers are here on the left and right side. This is the whole domain they are asking. So minimum we know at this x equal to 0. Okay, at this point. Yes, no maximum because it is going, this curve is going. Okay, we don't know when it will end. So it's a minimum because the domain is this R domain is it includes all the numbers, so we don't know the maximum. There is hence no point of maximum value. That's important here. But here you see, if you restrict the domain instead of R, if you make this closed interval, let us say -2 1, then there is a maximum value. Okay, that is important here. Instead of this domain R, if you replace that with this interval, closed interval, then there is a maximum value. So what is the difference between this curve and this curve? So this here at 0 it is a smooth turn, that is differentiable here, but here this is a sharp turn, not differentiable. Okay, so here you will see, here also no maximum point, no maximum value, but one may note that the function f in this is not differentiable at x equal to 0. Because there is a sharp turn here, we will see dy by dx. Here we cannot differentiate here in this, but there is a smooth here. That is the difference between the 26 and 27. Otherwise same. Maximum annual, here you will see they changed the domain. 0 1 excluding, this is the open interval. Yeah, between 0 and 1, not including 0 and 1, not including 0 1. Okay, you should remember what is this bracket, and that is square bracket. Okay, so here the given function has neither the maximum nor minimum value within this interval, because this is not 0 and 1 is not included here. Okay, you should know how to, when you written 0 and is written like this. This is a closed and this is open interval. The remark is very important here. Reader may observe that in example 8, if you include the points 0 and 1 and the domain of f, we extend the domain to, this is a closed interval. The function has a minimum value at 0, maximum at 1. But here in this example, this is given like this, that is not including 0 and 1. So it doesn't, it neither a maximum value nor as the minimum value. But in this remark, if we include 0 and 1, it has a maximum minimum value. Every monatomic function assumes it maximum value at the end points, that is 0 and 1 here for this thing. Monatomic means either increasing or decreasing. Okay, it cannot be increasing and decreasing, it should be either increasing, that is called monotonic. These are the turning points from decreasing to increasing or vice versa. These points called turning points. See, these are here from decreasing to increasing. This is a turning point. From here increasing to decreasing, this is the turning point. Hill, valley. Turning points are A, B, C, D. Okay, this is called hill and this is valley. Okay, hill, valley. So here you can say this is a local maximum and this is local minimum, not overall. Within this some interval, this is within some interval, this is a local maximum, local minimum. What is local minimum and what is local maximum, we can read this. So here also you should understand what is this definition of this local maxima means, what is this definition, local minima, this definition. Okay, here f dash of x is 0, f dash of z is 0 in this, that is slope is 0. Here increasing, decreasing, here also 0, decreasing, increasing. Local minima at x equals 3, okay, f is not differentiable at c. If f has a local maxima or local minima at x equal to z, then either one of these is satisfied, f dash of c equal to 0 or f is not differentiable at c. Not differentiable, we have seen the sharp turn above example 27 I think. So like that, f is not differentiable or f dash of c is 0. Point of inflection here. A point C in the domain of a function for which f dash of c is 0 or f dash of f is not differentiable is called critical point. Okay, f dash of c is equal to 0 or f is not differentiable is called critical point. First derivative, only one differentiation. First derivative test. So again these definitions you should read and understand by looking at the problems. Okay, how they use those definitions. Point of local maxima, point of local minima, points of the non-differentiability, these sharp turns, point of you cannot differentiate the function here sharp turns. So here how we are finding the derivative, then when the derivative is 0, so how to find when this derivative is 0, then you have to factorize, then only you will find out at what values of x this derivative f dash of x will be 0. Okay, f dash of x is 0 at x equal to 1 and x equal to minus 1. This is after factorization. So I think you call that roots of the polynomial in your previous classes, previous standards. Local maximum, local minimum. Case 1, when x equal to 1, this is the one. So okay, x equal to minus 1. So you can again go through this. You should always match how they are using the FO definitions, that is rules. Point of influence is neither a point of local minimum, local maxima, nor a point of local minima. Neither a point of local, that is called a point of inflection. So here also the second derivative, that means we are doing one more differentiation here. Second, these definitions, then how they are using the definitions to find the local minima maxima. Okay, given function is not differentiable at x equal to 0 because of the sharp turn here. So the second derivative test fails. First derivative test, go and read above. Okay, so again how they are using the derivatives. So you should know how to factor this to find out where this function will be 0, f dash of x will be 0 at this values of x and this. Okay, so you go through this. So whichever test is easy for a particular problem you use. Reader may note that in example 35 you use first derivative test instead of second derivative test as the form is easy and short. So these are all solved, you can easily understand, just read it. Okay. So here we are going to find out maximum minimum for a closed interval, that is this is open interval, then with a square bracket closed interval. Observe that the function 0 neither has a maximum value minimum value. Closed interval you should write like this. Okay, square bracket, absolute minimum value, maximum value and absolute minimum value. So again these theorems, these definitions you should understand. If there will be 0 if f attains its absolute maximum value at C, 0 if f attains absolute minimum value at C in the closed loop. Okay, these rules all critical points. You will see an example how they are using the rule. Okay, step 1, these are the critical points after differentiation. These are the critical points. F dash of x 0 which gives x in this step 1. This is the step 1, so not differentiable. This is the f dash of x is 0 or f is not f dash of x is 0 at these points. That is the critical point, these points. F dash of x is 0. Okay, because x equal to 2 if you take this will 24. Okay, 24 plus that is 60 and this will become 60. So at this point this is f dash of x 0, 3 also is 0. Okay, so that is step 1. So in the then you have to, in the step 2 what they are asking, take the endpoints of the interval. Here endpoints. Okay, 2 and 3 are the endpoints in the interval they are asking. Okay, 1 and 5. Okay, between the endpoints 1 2 3 5. So now you find the values at all these points. Calculate the value of f. Okay, calculating value of f of all these points, then identify the absolute maximum minimum. Okay, from this absolute maximum is this value, absolute minimum is this value 24. Okay, so these steps given in this definition, how they are using, you should read the step and understand the problem. Similarly for this, so here f dash of is not defined for x equal to 0, because if you put x equal to 0 here then it will become infinite. So here x is defined but we are finding the roots, but here x is not defined. So this is the practical problem on how they are using this absolute maximum minimum thing. Okay, you go through this. Okay, these are some miscellaneous problems. In each topic you should try some problems yourself. Okay, A summary, you read the summary. See, in the calculus, that is chapter 5, 6, 7, 8, you should know the differentiation and integration, basic differentiation and integration. Then only you will be able to solve the problems in the calculus. That is continuity and differentiability, application of derivatives, integral, then application of integrals. Okay.